Okay, in this video we're going to look at doing an example titration calculation from a previous exam, and that will cover all the science understandings that we have here. Okay, so here's our question. The concentration of ClO- in household bleach was determined by titration using sodium thiosulfate and acidified potassium iodide. The steps for this procedure are shown below. A standard solution of 0.2034 mol per litre sodium thiosulfate was prepared. Calculate the mass in grams of sodium thiosulfate crystals with a molecular mass or a molar mass of 248.18 grams per mole used to prepare this solution in a 250 ml volumetric flask. So I always like to start off by writing out all the information in the question. So the concentration of the sodium thiosulfate was equal to 0.2034 moles per litre. The molar mass of that was equal to 248.18 grams per mole, and the volume was equal to 250.0 millilitres. Now that reason that 0.0 is there is it's trying to show us we have four significant figures here. So when we get to our answer at the end, we want to have four significant figures in our answer, but we also need to convert this to litres because our usual unit in chemistry for volume is litres. And the unknown it's asking about us is the mass. So I'll put that with a question mark. Now we don't have a formula that's going to tell us the mass from C, M and V. We're going to have to do this one in two steps. So in the first step, what we need to do is actually work out the number of moles. And often in a titration, that's what's important. So to work out the number of moles, the formula we start with is concentration equals number of moles over volume. If we rearrange that, we get number of moles equals concentration times volume. That's equal to 0.2034 times by 0.2500, and that's equal to, I'll just pause and calculate, it's equal to 0.05085 moles. So now that we know the number of moles, we can convert that to a mass. So again, the formula there that relates those is number of moles equals mass over molar mass. So mass is equal to number of moles times molar mass, which is equal to 0.05085 times 248.18. And that, if we put it into our calculator, comes out to be 12.62 grams. If you're playing along at home, you do just need to round up that from 619 to 62 grams. Okay, so then a volume of 20 ml of the bleach was diluted to 200 ml, so 20 ml of that solution, 20 ml of the original bleach was diluted to 200 ml. Then 25 ml of the diluted bleach was mixed with an excess of acidified potassium iodide solution to ensure that all of the ClO had reacted. The equation for this reaction is shown below, so ClO- plus 2 iodide plus 2H plus forms iodine plus a chloride ion plus water. This mixture was then titrated with sodium thiosulfate solution to react with the iodine. The equation for this reaction was shown below. So what's going on here? For every one of these ClO minuses, we will form one iodine. So ever how many iodine are present equals how many moles of ClO minus must be present. Then in this step we work out the number of moles of iodine because we react it with the thiosulfate. But there's a catch here, and we'll go through this in a sec, because for every 1 mole of iodine that forms, we need 2 moles of our standard thiosulfate solution. So we need twice as many moles of this as this, because there's no number in front there. So basically we assume that means there would be a 1 there. So for every 1 mole of iodine, we need 2 moles of thiosulfate. So in the next part it tells us the average titer, so the volume, or an average volume of the 0.2034 sodium thiosulfate solution, so this standard solution we made here, the average volume obtained in step 4 was 33.94 millilitres. And it's asking us to calculate how many moles of thiosulfate were in 33.94 mil of 0.2034 mole per litre sodium thiosulfate. So again, let's write down the information in the question. Concentration is equal to 0.2034 moles per litre. The volume is equal to 33.94 millilitres. And I hear you all yelling, change that to litres, and you are correct. Oops. So I'm just dividing that by 1,000 to convert millilitres to litres. But basically just moving the decimal point 3 places. Then number of moles equals concentration times volume. We've already done that over here, so I've done that rearrangement before. I don't need to show that again. And that is equal to 0.2034 times by 0.03394, and I'll just pause to calculate that. So that equals 6.903. The next digit is the 3, so I don't need to round up. That's given me 4 significant figures, times 10 to the minus 3 moles. Now it asks us to calculate the moles of iodine that reacted in step 4. So we know this many moles of thiosulfate reacted, so this number here, 6.903 times 10 to the minus 3. How many iodine there must have there been? So from this, it's telling us for every 2 of these, there was 1 of these. So there's half as many iodine. So you could just times that by half, get your answer, do it in 1 step, 1 mark. You'd get full marks because it's 1 mark. But I will show you the process that you can use to do that. So if it is a little bit harder, that you always remember this. So it's asking us to calculate the number of moles of iodine. So that's our unknown. So if we set this up, number of moles of unknown over number of moles of known, which is the thiosulfate. So I'll write that in now. Number of moles of our unknown is iodine over number of moles of thiosulfate, which is our known. Hope I said that right. I'm a bit worried now. Now, the numbers we put up here in this, like a fraction, is straight from this equation. So the number here for iodine is 1. The number for thiosulfate is 2. They're our stoichiometric numbers for this equation. So we just put them in there like that. And then we can rearrange that equation. So it says number of moles of iodine equals 1/2. And the thiosulfate concentration basically comes up to the top when we rearrange, or you can think of it as timesing both sides by that. So that becomes equal to 1/2 times by 6.903 times 10 to the minus 3. So I can do that very quickly on my calculator. and we get 3.45. Now that's a 1/6, so I'm going to round that up, times 10 to the minus 3 moles of the iodine must have reacted in that reaction, which, as I said, is half that number. But hopefully if you just see this process here, you might need this if it's a slightly harder question. So now we need to calculate the concentration in percentage weight volume of ClO minus with a molar mass of 51.45 in the original solution, in the original bottle of household bleach. So we know the number of moles of iodine is equal to 3.45 2 times 10 to the minus 3 moles, and from this equation here, for every 1 mole of iodine there would have been 1 mole of ClO minus. So they're equal, and we know that the volume of ClO minus would be, I'll just label that so it doesn't get confusing, was 25.00 millilitres for significant figures, which is equals 0.02500 litres, keeping that for significant figures, so that the concentration of that ClO minus solution is equal to the number of moles divided by the volume, which is equal to 3.452 times 10 to the minus 3 divided by 0.02500, and that's equal to 0.138, and then I've got a 0.6, so 6 is greater than 5, so I'm going to round that up there to the 1 moles per litre. But now we need to take into account that we did a dilution up here. So we diluted 20 mil into 200 mil. So we diluted by a factor of 10. So to take into account the dilution, before the dilution, the concentration of ClO minus would equal 10 times 0.1381, which would equal 1.381 moles per litre. And then finally we need to convert this into percentage weight volume. So that's going to be 2 steps on that. If you look at the notes from the first volumetric video, the first thing that we need to do is, if we want to take moles per litre to grams per litre, is that we need to times by the molar mass, and then if we want to convert that into percentage weight volume, we need to divide that by 10. So we go 1.381 times by 51.45, just get that from up here for ClO minus, and then we could work that out, but we're just going to take all of that and divide that by 10, and that's going to give us our final answer. I'll just pause and calculate. And that equals 7.1035, so we round that up to 4, and that's either grams per 100 millilitres, or really that's the same as percentage weight volume, which is what the question asked us for.